So in this question, a student carried out an experiment to investigate the amount of energy stored in a potato crisp. He placed 22.5 cm cube of water into a test tube and recorded the temperature. He then placed a crisp of mass 1 gram in a holder, as you can see, and set light and then place it under the test tube. Once the crisp has finished burning, the student record the final temperature. The experiment was carried out 3 times. So initial temperature was kept same and the final temperature was different. Use the student data to show that the energy released by burning a crisp is about 2,900 joules. The density of a water is 1 gram per centimeter cube and the specific heat capacity is 4,190 joule per kilogram degree centigrade, joule per kilogram Kelvin. So we have the formula for like what we'll do, we'll work out as the experiment is repeated thrice. So we'll take an average of the temperature change. So the energy which is absorbed by the water is equals to Cm delta T, where C is a specific heat capacity 4,190. M is a mass. The mass of the water is same as the volume of the water because it has a density 1 gram per centimeter cube. So if 22.5 cm cube, the mass, because the density is 1, so it will also have the same mass as the volume. So this will be 22.5. And now about the temperature change, what we do, initial temperature is same, so final temperature will take an average. So how to take an average? We add them and divide by 3, so this will be 52.5. And so average final temperature is 52.5. So when we take a temperature difference, it will be 52.5. And average initial temperature, when we take an average, because it's the same number, 21.5. So average will also be 21.5 minus 21.5. So E, the energy, equals to Cm delta T. So when we multiply them all, this will be 2,920 joules. The next part, explain one precaution that the student should take when carrying out the experiment to make the energy calculated as accurate as possible. Like how student will make sure that this experiment is done accurately. Normally, when we are heating the water, because the water convection current, the energy transfer by convection. So if we stir that, it will have a, because throughout the liquid, it won't have the same temperature throughout. So we should stir the liquid so that water has the same temperature and we can find the average temperature. Otherwise, if a thermometer is placed at thermometer bulb is placed at the bottom or near the bottom of a test tube, it will record a different temperature as compared to near the surface of a liquid. That's why what we should do, we should stir with a thermometer to record so that through water has the same temperature throughout. So we should stir. So that precaution will take, like water should be stirred or stirred. So water is all at same temperature. So same temperature throughout. Or we should also keep the crisp close to the test tube so that it won't lose too much heat energy to the surrounding. It states on the crisp packet that the energy per gram is 21.9 kilojoule. Compare the value calculated from a student data, suggests a reason for the difference. So it's stated that for if we burn 1 gram, it will give this much energy, 21.9 kilojoules. So when we calculate, our answer was for the first part, it was 2,920 joules. And when we burn 1 gram. So 2,920 joule, which is about 2.2, 2,900, 2,000. The first answer was 2,920 joules. If we convert into kilojoule, so it will be 2.9 kilojoule, kJ. And compare this value with the calculated value from a student data and suggest why there's a difference, why there's a difference between the two values, or why the two values are not equal to each other. Because this 21 kilojoule, like 21.9 means like 21,900 joules. So this is 21,900, but we got only 2,000. So there's a very big difference. And why there's a big difference between the calculated value and the, like, why there's a much difference between the experimental value and the actual value, the which is stated value, because the main idea is that not all of the energy will transfer. Second thing is, still not all the particles will burn in the crisp. So two reasons why the calculated value and the theoretical values are having a much difference, because some of the energy will be lost to surrounding, and second thing, all the particles in a crisp will not burn. That's why we don't get the total energy from it.